A body of mass 0.4 kg moving initially with a constant speed of 10 meter per second to north is subjected to a constant force of 8 Newton directed towards south for 30 seconds. So initially, that means at time 0, the body is moving with the speed of 10 meter per second towards north. Since the force is towards south, the acceleration is also towards south. So this is the speed towards north, the acceleration is towards south. That is force divided by mass. So it is 8 by 0.4. So this is 20 meter per second square. So this acceleration is towards the south. The body is moving towards the north direction. So it will slow down. Okay. Now the force acts for 20 seconds. So this acceleration is only for a total time of 20 seconds. Take the instant the force is applied to be at t equals to the position of the body at x equals to 0. Predict the position at -5, 25 and 100 seconds. So -5 seconds means 5 seconds before the force started acting. Okay. So let me show this graphically. It will be visually more understandable. So this is the position time graph of the body. As usual, the x-axis being the position and the y-axis being the time. I mean, okay, this is not usual. But anyways, that's not important. So I'll take the usual thing. So this is the xt graph. Okay. So at time t equals to 0, the body starts having force. The body starts experiencing force. But before that also the body was moving with 10 meter per second. So we'll take this to be 0. Now after this, the force changes the speed of the body. Since the force changes the speed of the body, the speed decreases because the force is in opposite direction. The graph will go something like this. The graph goes something like this. Okay, till this point, before this point, the speed was constant, 10 meter per second. So before this point, the line would have been straight. So at -5 seconds, so this is -5 seconds, this is the x-axis. I have to plot time axis, so not this. This is -5 seconds. The body would be somewhere here. So we have to find this x. We have to find x at 25 seconds. So at some 25 seconds and x at 100 seconds. So I have to extend this line. So at 25 and 100 seconds, the position of the body has to be found. Okay. What will be happening visually if this is the straight line, this is towards north. So at time t0, x0, so both are 0 here, x and t, the body would be moving up with a speed of 10 meter per second. But since the force is acting, the body would slow down and come towards south. Okay, this is what would be happening in reality. Okay, so before 0 seconds, that is at -5 seconds, there is no acceleration. So at t equals to -5 seconds, we can simply use the equation for constant velocity, that is u equals to distance upon time. Therefore the distance would be u is 10 meter per second and time given is -5. So that is -50 meter. So at -5 seconds, the body would be 50 meters behind the 0. That is -50 meter. Okay. At 25 seconds, the body is experiencing a force. So simply the equation of displacement can be used. where we can write S at 25 seconds is ut plus half at square. So this is 10t plus half minus 20 25 square. So acceleration I'm writing is minus 20 because it is opposite to the direction of initial velocity. Okay, so this becomes 250 minus 6250. So this is minus 6000 meter or minus 6 kilometer. So at 25 seconds the body would be at minus 6 kilometers. So the body would be downwards. So the x would be way negative at 25 seconds. So the x would be way negative. So somewhere here at minus 6000 meter. Okay. Now the third part is little tricky. The third part says the position at 100 seconds. The force is only acting for 30 seconds. So we have to split this time 100 seconds into 30 and the remaining 70. So for 100 seconds, I'm taking two time intervals, 30 seconds in which the body experiences acceleration and the remaining 70 seconds which will be uniform speed or uniform velocity since there will be no force. Okay, so in the accelerated motion, simply we can find S T1 to be ut or ut1 plus half at1 squared. This is 10 30 plus half minus 20 30 squared. This is 300 minus 9000. So this gives us 8000 or minus 8700 meter. So this is the distance covered by the body in 30 seconds. Now in the remaining 70 seconds, the body would be moving with a constant speed. So first we have to find out that speed. So v at 30 seconds. This would be u plus at2. This is 10 minus 20 times 30. So this is 10 minus 600. So 590 or minus 590 meter per second. So after 30 seconds, the body would be moving south with a speed 590 meter per second. The distance covered x would be vt, where v is minus 590. The remaining time is 70 seconds. So this distance comes out to be 41,300 meters. Okay. So this is the distance covered in the remaining 70 seconds. This is the distance covered in 30 seconds. So the total distance covered in 100 seconds would be the sum of these two. So this is 50,000 minus 50,000 meter or minus 5 kilometers. So the distance covered in 100 seconds would be minus 5 kilometers, not the distance covered, the displacement of the body. The body would be at minus 5 kilometers. Okay, ignore all the places where I've been seeing distance. This is not distance, this is the final position of the body, minus 5 kilometers. Okay, I hope this is clear.